Hello and welcome back to another VMK for the game development series. If you find my videos helpful and you'd like to support my website, you can do so by going to www.maticnodes.com and clicking on any of the ads found on the side or clicking on the PayPal icon. In this tutorial, I'll be showing you how to start constructing the light class. Now, this tutorial is going to be broken up into a number of parts. The first part I'm going to be showing you here, where we're going to be constructing the initial class for every single light that we're going to be using. Now, there are three possible lights that OpenGL can render. There's a point light source, a directional light source, as well as a spotlight. Now, all three of these have common attributes, such as position or direction, color, things like that. So what I've done is I've created one class, which I call it the NodeLight, and this is going to be the parent class for all three of the specific light sources. So each of the specific light sources is going to inherit from this light node, and it's going to have functions to set the light node and do other things that are just specific to the light. But things that are general for every single light are going to be defined in this light node class. Now, the reason why I call it light node rather than light is because eventually everything that we create in this game engine is going to go into a scene graph. And in a scene graph, you end up having nodes as well as transforms and objects and things like that. So what we're starting here is sort of beginning constructing the scene graph. So let's begin with the light node. To begin, we need to create a .cpp file and a .h file. Everything's going to go into the scene library. So let's go into the Solution Explorer here under Scene Library and right-click and go Add New Item. I'm going to select the header file first, and we're going to call it NodeLight. And just repeat that for the CPP file as well. Okay. Starting with the .h file, let's see what we have here. At the top, we include the core, the color, OpenGL, and vector3.h. Then we have an enumeration here of the different light types. So as I said, this light node class will be able to distinguish between three different types of light: a point light, a directional light, and a spotlight. The point light is going to be a light source which is represented in the 3D scene at a specific location. And at that specific location, it's going to be shining in every single direction. So the direction of a point light source is irrelevant. A point light source, you can think of it as the equivalent of a light bulb. If you can place the light bulb somewhere in the scene, and then when you turn it on, it's going to illuminate the scene in every single direction, about equally. The directional light is something equivalent to that of the sun. It has a direction, but it doesn't really have a position. So you can imagine the sun is up in the sky somewhere, and all the light is coming down in one direction. So if you're, how can I explain this? If you have an object that's sort of in front of this light source, it's going to illuminate it from the one side. But if you walk around the object to the back side of it, you'll see that the back side of this object is not illuminated. So the direction does matter for a directional light source. The last type of light is a spotlight, and that's equivalent to that of something like a flashlight. So you have a position for this light source as well as a direction, and the further you go from a spotlight source, the more the light opens up. So you sort of get like a cone shape, almost like the front end of a car, like the car headlights. If you look at a car in the dark, you can see it sort of creates a cone of light. Well, that could be represented as a spotlight. Okay, now let's take a look at the classes. The main class itself is called NodeLight, and it has a constructor which takes the type of graphics renderer we're going to be using. It has a virtual destructor. It has an initialization function which which actually I decided not to use this, so we can delete that. We won't need to initialize. We have a disable function here, which is used to turn the light source off. There's a function here to set the light to be on, and we can use this to turn it on and off, whereas this one here is actually used to for the OpenGL renderer to turn it off. This is just to set a flag. This is to actually do the work. There's a function here called isOn that returns true or false depending on whether the light source is turned on or off. Then we have some set and get functions for the 3 different color codes that a light source can contain. Light source will have ambient color, diffuse color, and specular color. Ambient color is the overall color that the light source emits, and it doesn't depend on direction or anything like that. Diffuse color is directional dependent, so depending on where the object is relative to the light source, a diffuse light will make it shine differently. Specular color is used to give highlights on the surface of an object. So if, imagine looking at a very clean, shiny apple. If you look at a clean, shiny apple, you'll see that it has a specular highlight on it, which is really, really bright white. But then as the further away you get from the specular highlight, you see more and more of like the red color or the green color of the apple. So that's what specular color is. Then there's a virtual function called render, and it's a pure virtual function, which means that you're not allowed to use this NodeLight class directly. You have to use it through one of the inherited members, which we'll be constructing in the following tutorials. Then the member variables which are contained in the NodeLight class are, there's a static member variable, which is an integer, and it holds the maximum number of lights. And what this means is the number of lights that your video card can render at any point in time. Usually the number is around 8, but higher end graphics cards might be able to handle more. So if you're designing a game, remember you most likely will not be able to render more lights than 8 at one point in time. So if you have a really complex scene, like for instance you're building a game where a player is running around in a dungeon and the dungeon is lit up by torches, well, you have to make sure that the way you organize your game, you can only ever have 8 torches within view of the player. Because if you have more than that, OpenGL will not be able to render the light sources for those torches. Now this doesn't mean that your entire dungeon has to have 8 torches. You can have 100 torches in your dungeon. However, you have to be very smart in when you turn torches on and when you turn them off. So if a player is facing down a corridor and he has, for instance, 10 torches behind him, 3 torches in front of him, don't bother rendering the 10 torches behind him because you're wasting those render slots, because the user won't be able to see the light anyway. So render the things in front of the user, the 3, which will leave you 5 light sources left over, and you can use that for other things. So this maximum number of lights is very important. Then there's a light type member variable, so this here will hold which of the following 3 light sources this current light will contain. Graphics render member variable, a boolean value for on or off, a light ID. This ID number we'll be using within the scene class to identify which light source we're playing with. So you'll see in a later tutorial, inside the scene we create our light sources, and then as soon as we create a light source, the function will return an ID to us. Then by using that ID, we can decide when we want to turn on the light source, when we want to turn it off, and do other things with it. We have our member variables for the 3 different colors. We have some member variables here for exponent, cutoff, and attenuation. Exponent and cutoff are used for the spotlight exclusively, and attenuation is used to figure out how the light source is dimmed with distance. So you realize that if you have a light source at point 000 and you're standing, for instance, 1 unit away from it, the light source will be bright. But as soon as you step maybe 100 units away, then the light source will get dimmer. Well, that sort of dimming effect is contained inside this attenuation factor. And then we have some member variables here for position as well as direction. So we can control where the light source is positioned as well as in which direction the light source is pointing. Okay, so that's our light node. Now let's go into the CPP file and start writing these functions. First thing we have to do though is we have to initialize our static member variable. We noticed here that in our class, our NodeLight class, we define the static integer for the maximum number of lights. Well, for us to be able to use that, we need to initialize, or in other words, give some memory to that static member by doing the following. So int NodeLight, 2 colons, the name of the variable, and then I'm setting equal to 0. So initially, this static member variable has a value of 0. We can't initialize this inside the constructor because it's static, so it has to go outside of the NodeLight class. Our constructor is next. In here, we initialize all the other member variables for our class. And again, we're passing in the renderer, so whatever we pass in here gets saved into our member variable. By default, I'm just going to set the light type to be a point light source. This won't actually really matter because we can never initialize NodeLight directly because it's a pure virtual class. But I just do this just so that there's some value within all of the member variables. So I just chose point. Automatically, we turn that light source off. We define the ambient color to be black. The third parameter here is the alpha, so we have red, green, blue, and then alpha, and I set the alpha to be 1, which means it's completely visible. The diffuse color I set to white. Specular color I set to white as well. Exponent and cutoff I set to 0 and 180 degrees. Attenuation is 100, which means this is going to be linear attenuation, and then it doesn't have quadratic attenuation or anything like that. Position, we set the position to be at 000, and the last parameter here is the W value. I'll talk about this in more detail when we talk about the specific lights, because this parameter actually means different things depending on which light source we're using. So I'll talk about that a little later. And then direction, I just specify that the light source is going to be pointing in the -1 direction in the Z, so it's going to be sort of pointing into the screen if you have a spotlight. And then depending on which renderer we use, the following happens. We enable the lighting because if we're going into this constructor, that means we're creating a light source, which most likely means we want to be lighting, or we want to be using lighting. So I enable lighting in OpenGL, and then I enable GL color material, which allows us to use their existing code, which has all of our GL color function calls, to set all those colors to be a material. The way that OpenGL works is when it calculates the color of an object, it needs to know the material of an object as well as the color of the light source. Those two values get multiplied together to give the overall look on the screen. Well, we haven't used the material anywhere in our existing classes here, but by using GL enable GL color material, we're basically saying whatever color we've specified already, use that as the material. So that's what this does here. And then the last thing this function here does is it returns to us the value of the maximum lights that our video card can handle. So it returns that value and stores it in our static member variable. Now, if we're going to be creating one light source, everything goes through here and initializes. If we go and create a second light source, everything goes through here and reinitializes. So be aware that this static member variable gets rewritten a second time, and we re-enable the lighting and we re-enable the color material. This isn't really ideal, but this is sort of the best way that I could figure out to do it that's sort of compartmentalized. Initially I had a initialize function within the NodeLight, but I found it started getting really annoying because when I created a light, I had to go initialize it. But then every time after that, when I created a light, I didn't need to initialize it. So I needed to remember to initialize the first time. So I got rid of that, and instead I created the switch statement inside the constructor that did the initialization automatically for us. Okay, so that's the constructor. Let's see what's next. The destructor doesn't do anything, so it's just blank. The next function is called disabled, and we use this to disable the light and actually turn it off so you can't see it in the scene. So what we do is, depending on the switch statement, whichever renderer we're using, for us it's OpenGL, we're going to be selecting the light ID number, and the light ID number gets called by using this constant value saved in OpenGL. This constant value points to the very first light object that we can store, and then we add the light counter number, which gets passed into this disable function. So from the outside, we're going to be passing in a number into this light counter to select which light we want to turn off, and then we're going to create an ID number based on that light counter number, and we're going to call GL disable to disable that specific light. We have this function called setOn, which is used to turn the light on and off. Now, we don't really call GL disable here in setOn, because what we do is we set this member variable beyond to be true or false depending on what gets passed into us. And you'll see in the rendering function for each of our lights, if a light is turned on, so we check our member variable for this. If it's on, then we go and render it. If it's off, we just skip it completely and we don't render it. It'll make more sense to you once we actually finish implementing the light class. IsOn returns true or false depending on whether the light source is currently enabled or disabled. So it just returns our member variable. Next we have our set and get functions. So we can set the ambient color, which we pass in an OpenGL color code here, and the red, green, blue, and alpha values get passed into the member variable for our color for ambient. To get the ambient color, we need to return a pointer to a floating point number. So all we do is we return the address of the first element in color ambient, which is a member variable for us. With this pointer, we can then go and retrieve the other elements, for instance the green, the blue, and the alpha, automatically. The remaining functions for diffuse color and specular color are exactly the same. So for diffuse color, when we set it, we pass in an OpenGL color code for red, green, and blue. We pass those directly into each element of the member variable. When we call the get, we return the address of the member variable for the first item inside the diffuse. For specular, again, the same thing, red, green, blue, alpha gets passed into each of the separate elements for the specular color, and then the get, we return the address of the first item for the specular color. And that's it. Let's try to compile this, make sure that everything's okay. Yep. So that's our NodeLight class. And again, we can't use this class directly because it is purely virtual. And it's purely virtual because we have a virtual here setting equal to 0. In the next tutorial, we'll be creating the point light source, and then once we have the point light source, then we can add a point light into our scene.